All right, so this is section 4-1, quadratic functions and transformations. Our learning objective is to identify and graph functions. And when we graph a quadratic function, it is called a parabola. So when we see the graph, we can call those parabolas. And a quadratic function has the form ax squared plus bx plus c. So unfortunately, the quad doesn't have to do with the degree of our polynomial. Okay, so our essential understanding, which you do not have to write down. You do have to write this definition, these two definitions down. The graph of any quadratic function is a transformation of the graph of the parent quadratic function, y equals x squared. So any other quadratic function, any function with the x squared or less in it, is just a translation of the parent function y equals x squared. When we write a quadratic function as a parenthesis x minus h close parenthesis squared plus k, that is called the vertex form of a quadratic. Where our h is here, we have an axis of symmetry at x equals whatever our h value is, whatever our x coordinate for our vertex is. We get an axis of symmetry. After you write this down, we're also going to draw the picture. The vertex of the parabola is at h comma k. It's at this coordinate. The x coordinate of our vertex is h. The y coordinate of our vertex is k. Okay, so you're going to draw this little sketch. We already have this information up here. So I want you just to draw the sketch of a parent quadratic function on your paper. Okay. So when we're looking at a graph, we're always going to start compare it to the parent function. So we're going to plot, so we have, what is the graph of f of x equals negative 1/3 x squared? So I know I don't have any vertical or horizontal shift, so my vertex is going to be at 0, 0. This is going to. So the vertex is at 0, 0. The axis of symmetry is at x equals 0 because it is the x coordinate of our vertex. So we're going to put a dashed line at x equals 0 to show that's our axis of symmetry. Step number 2, we're going to find and plot 2 points on one side of the axis of symmetry. So I'm going to go x and then f of x. So 1 point on the right-hand side, and I'm going to pick these strategically. It's not going to be by accident. I'm going to go ahead and pick 3. So when x is equal to 3, f of x is equal to negative 1/3 times 3 squared. 3 squared is 9. 9 times negative 1/3 is negative 3. So my first coordinate is going to be at 3, negative 3. My axis of symmetry says I'm going to have another point that is reflected across the x-axis the same distance away. So my negative 3 is also, when x is equal to negative 3, my function is also going to be equal to negative 3. So we plot that point and then sketch our curve. And this guy is a little fatter than our parent function because of the 1/3. He is facing down because he has the negative, so we know he is reflected across the x-axis. And that's how we sketch a parabola. All right. Key concept: reflect, stretch, compress. This is not new. We've talked about these three things before. So a reflection, a stretch, and a compression. So remember, if we have negative in front of our x squared, we are a reflection. If we have our a value, so our coefficient in front of our x squared, if that is greater than 1, it stretches the parabola. Makes it real skinny. If we have an a value, so the coefficient in front of the x squared, if it is between 0 and 1, then it gets fatter, just like our 1/3 was a little bit fatter. All right, these are important little items. If a is greater than 0, the vertex is a minimum value. So if your parabola is facing up, because your a value is positive, and right at the belly button of your vertex, that's going to be the minimum. If your vertex is a frowny vertex, so he is facing down, then when your atoms are full, your arms are the parabola, and they're facing down, and your Adam's apple is a maximum. So if you have a smiley face parabola, he has a minimum at the vertex. If you have a frowny face parabola, he has a maximum at the vertex. Very intuitive. Okay, so we're going to graph a couple of functions here and see how it is a translation of our parent function. Okay, so when we add to our parent function 3, what does it do to our parent function? So I'm going to put the parent function in red. So that you guys can see how we move stuff around. This function here, g of x equals x squared plus 3. When we add values to the end of our function, it moves our whole function up 3 units. So instead of a vertex at 0, 0, the vertex is going to be at 0, 3. There is no stretch or compress. And it's just going to fit right inside. Same as our other one, just moved up 3. If I look at h of x equals x plus 1 squared, when I have adding inside of my function, so inside of that x squared. So I'm adding 2 inside of the x squared. So let's wrap up this one. F of x equals x squared moves up 3 units. So for a, the translation of f of x squared is moved up 3 units. So that finishes out a for us. B, when I have adding inside my squared, that is a horizontal shift. Adding means we go left. So it's a shift of 1 unit to the left. So instead of my vertex being at 0, 0, it is now at 1, 0. So this one is f of x equals x squared, moves left 1 unit. Okay, let's make it more complicated. So we're going to take a look at a quadratic function, and we are going to determine the vertex, axis of symmetry, minimum or maximum, and the domain and range. So now we're going to take this to a new level, find more information. So we want to take our y equals a parenthesis x minus h squared plus k. That is our vertex form. We are going to compare our original function directly with this form. So I'm going to identify which one is h and which one is k. So up here I have x plus 1. This down here says I want x minus our h value. Well, the only way to go plus 1 is to go minus negative 1. So the x coordinate of our vertex is negative 1. I like to think of it as it's the opposite sign of whatever is in that parenthesis. And then our k is the 4. And that's our vertex. All right, our axis of symmetry is always x equals whatever the x coordinate of our vertex is. So whatever our h value is. So our axis of symmetry here is going to be x equals negative 1. So my parabola is going to be centered around x equals negative 1. It's going to mirror itself around that line. And since a is less than 0, the parabola opens downward. All right, so axis of symmetry, minimum, maximum. So if it opens downward, he's a frowny, so his vertex is a maximum. So when you open downward, you have a maximum at negative 1. So my domain, if we look, anytime you're thinking about domain, you want to say, are there any numbers that I cannot put in that either make a denominator equal to 0 or a square root negative? And we are not even anywhere close to this scenario. So the domain of this function is all real numbers. The range of this function, now think about this, think about it logically. What is the maximum y value I will ever have? What is the very biggest y value? 4. So that's our maximum. So our range goes from y less than or equal to, or f of x, I'll say y, because I use y less than or equal to 4. You can also write it as negative infinity to 4 with a bracket because the bracket's included. 4 is included. If 4 wasn't included, it would be parentheses. That's bonus today. All right, so translation of a parabola. We know how to translate stuff. This is just what we talked about. So when I have anything moving horizontal, is going to happen inside this squared term. So I'm either going to minus or plus from the x in the x squared, and that's a horizontal shift. When I shift it horizontally, my vertex becomes h comma 0, so whatever the opposite inside these parentheses is becomes the new x-coordinate of my vertex. If I want to move it vertically, I just add to the squared function, and my new vertex becomes 0 comma k, so whatever I'm shifting up or down. And if I add those together and have a vertical shift and a horizontal shift, then my new vertex becomes h comma k. And we bring it all together. All right, so let's take a look at y equals 2 parentheses x plus 2 close parentheses squared minus 5. We are going to talk about what steps transform the graph. The first thing that I notice is the 2 in front of the parentheses. What does that 2 in front of the parentheses do to our graph? It stretches it by a factor of 2. That's the first thing that happens. Then I notice I got the plus 2 inside of the parentheses. What does that plus 2 inside of the parentheses do to our parent function? This x plus 2 moves our function 2 units to the left, and then lastly but not leastly, subtracting 5 from our function. What does that do to the parent? Pops it down 2. Pops down 5. So without even graphing anything, just by looking at the equation, we can know what our translations are. Alright, now we got the dolphin problem. We're going to write a quadratic in vertex form. This picture shows the jump of a dolphin. What quadratic function models the path of the dolphin's jump? The first thing we want to find out is what is the vertex. So you want to imagine this line continues on. So we can see that the vertex is at 3, 7. So we have a vertex at 3, 7. So we're hunting for this. We want to we're looking to fill in A, H, and K into our function. Our vertex is H comma K. So now that we have H and K, we need to find the A value. So we're going to choose another point that is on our curve, and we're going to choose 9, 4. So we're going to take our function, we are going to replace H with 3. We're going to replace K with 7. We are, actually I wrote it, but I want to take it back. We're going to replace the x value with the x value of our point on our curve. So in this case, we're going to replace it with 9. A is an unknown quantity. We don't know what our A value is. And we're going to replace the y with our y coordinate from our point from the graph. So we have 4 equals A times 9 minus 3 is 6. And and that is, if we simplify it, 4 equals 36a plus 7. I'm going to subtract 7 from both sides. And I get negative 3 equals 36a. I'm going to divide both sides by 36.
Plus or minus 7? Or is it?
This is 4 equals a times 6 squared plus 7. Then it is 4 equals 36a plus 7. Then I subtract 7 from both
I didn't
sides.
see it. I thought it was.
And then I get a equals negative 1/12. So now I can put together my complete function. Y equals negative 1/12 parentheses x minus 3 squared plus 7. That's my function. That represents the dolphins leaping out of the water. All right, take a moment and summarize what we have learned today. We're not going to do the second part, so just delete it. Just like that. Summarize what we learned today, and remember our learning objective was to identify and graph quadratic functions, so make sure you include how the translations work. You can include the vertex form and the standard form. You can include the funky way it's quadratic even though it's a square term, etc., etc. Plenty of information today to get a good summary. And that's your 4-1 notes.